Here's an example where you're asked to find all solutions to a triangle with certain specifications. So angle C is said to measure 29 degrees 50 minutes, and then we have the lengths there of sides A and C. I went ahead and drew a triangle with those measurements, and now we want to try to find the missing pieces. So what we need to find is angle A, angle B, and side B. Those will be the missing three parts. Now, you're going to learn about law of cosines in the next section, but with law of sines is always preferable if you can use it. And you can use law of sines when you have a complete pair. So when you have an angle and the measure of the corresponding side. When you have a complete set like that, then we can use the law of sines to find the missing parts of the triangle. One other thing before I get started. So the way I started my last video example, we were given two of the angles, so it's easy to quickly find the third angle then, just do 180 minus the two given angles. But in this case, we only know one angle, so we can't start with that quick and easy 180 minus whatever. So no, all right, I'm going to use the law of sines. I'm going to use side C and angle C, and then I got to set that equal to something where I know at least one of the quantities. I can't set it equal to. Well, let me write down what we know. So we know. Let's see. That sine of C is. Well, C is 29 degrees 50 minutes. We know side C. So we could set that equal to either sine of A over side A or sine of B over side B. I don't want to go with the B's because I don't know either one of those quantities. I don't know the angle or the side. So I would have two unknowns and I wouldn't be able to solve. So I need to go with angle A. And this is why, by the way, I've set it up with the sine of A on top. You can set it up as long as you set them up the same way. So if I put sine of A on top here, I need to have the sine on top here. It doesn't matter if you write it with the side on top or with the sine on top, as long as it's consistent across the equation here. The reason I set this one up this way is because I'm trying to solve for this. I know the length of A, that's 8.61. And it's easier to solve these equations if you put the unknown on top. So whatever you're going to solve for, put that in the numerator. If I fill in what we know, so sine of C. C is 29 degrees and 50 minutes. And if you don't have the minutes button on your calculator, then you can say 50 out of 60, right? Because it takes 60 degrees to make 60 minutes, to make a full degree. So you have like 5/6 of a minute over here. Over the length of side C, so that's 5.21, equals sine of A, and then that's what we're trying to solve for right now. We know that side A has length 8.61. So to solve for sine of A, we can just multiply by 8.61 on both sides, so that'll cancel there. Okay, so if you do that, if you crunch these numbers and make sure you use the parentheses here, then sine of A comes out equal to approximately about 0.82212. Okay, and let me write that on a new page because we have to think about that a little bit. So we left off with this. Now I like to visualize the values of sine by thinking about the unit circle. And I'm going to focus on just the upper half of the unit circle here. So you know that maximum value up here, sine is the y-coordinate. The maximum value is 1 up here. So 8.82212 is somewhere about here. 2, whatever. You get two solutions. You get one solution in quadrant 1, and you get another solution in quadrant 2. So there are it's possible that there are two triangles. There are two different angle A's that might help us build a triangle with the specifications that we were given. Okay, so to find one of those solutions, you would use the inverse sine function. That's probably what you were thinking of. To get rid of the sine here, I could do the inverse function. So take inverse sine of both sides. Oops, -1. Okay, and so I'm going to call this A1. When you take inverse sine of 0.82212, you get about 55.3 degrees. And so that's definitely an angle in quadrant 1. That's our quadrant 1 solution over here. Okay, but there is also a solution in quadrant 2. If you set up that 55.3 degrees as a reference angle over here in quadrant 2, then to find the quadrant 2 solution, I'll call that A2, you could take 180, that would be the entire upper half of the unit circle here, and subtract the wedge over here. So subtract 55.3 degrees. And this gives you another possible angle A, measuring 124.7 degrees. So now we have to think about, see if this works out, if they're both possible. I'll go with the quadrant 1 solution. I probably need to get a new page. So let's say that A lies in quadrant 1. So that A1 solution was 55.3 degrees. Okay, and remember we had given information. Angle C was 29 degrees and 50 minutes. And then we had the lengths of side A and side C, which I guess I'll go ahead and jot down. C was 5.21 feet. All right, so the first thing we could do with what we know so far, I would definitely, as soon as I know two of the angles, I would go ahead and find the third angle. So angle B would be 180 minus the two angles that we have at this point, the 55.3 that we just found, and then the 29 degrees and 50 minutes that we found, or that we were given. When you enter this into your calculator, for the 29 degrees 50 minutes, I would do minus parentheses 29 plus 50 over 60, which if it's all right with you guys, I'm going to reduce to 5 over 6. You could divide top and bottom by 10. So I would put all of this 180 minus 55.3 minus that, and you should get 94.9. And so at this point, the only thing that's missing is side B. And you could find side B using the law of sines. So I'll put B equals blank. But so the way we would find that is B over sine of B, which we just found 94.9, equals, it's best to use the given information. So let's see, side C 5.21 over sine of angle C. So that's the 29 degrees, and 5 over 6, that's the 50 over 60 degrees, the minutes that are in a degree. Okay, and then to solve this equation, you would multiply both sides by sine of 94.9, so that it cancels here and you get B by itself. So multiply by sine of 94.9 here. Okay, and so when you input all of that into the calculator, make sure you don't actually need the parentheses. Let me erase that right there. But there is, I did have parentheses on the brain for one reason. When you press sine, if you have a TI-83, I think a TI-84 might do this also. When you press sine, it might open a parentheses. Make sure that you close it at the end of that angle. Otherwise, you're going to get the wrong answer. But when you enter all this into a calculator, you should get, let me see if I have it in my notes. Oh, I didn't write it down. Okay, let me crunch these numbers real quick. Make sure that you're in degree mode. sorry about that, 10.4, about 10.4. And these are feet. And there's one complete solution. Now, I won't go through all this because I don't want this video to be an hour long, but you would then go back and consider, okay, well, what if I go with that A2 that I found, which, I'm looking for that in my notes now. A2 was 124.7 degrees. Okay, so remember angle C was given, that's the 29 degrees, 50 minutes. And then side A and side C. But if you have two of the angles, then it's best to find the third angle. So this angle B2 is going to correspond to this scenario for A. So you do 180 minus the 124.7 minus 29 degrees and 50 minutes, so 29 and 5/6 of a degree. Enter all that into your calculator and you get 25.5 degrees. And here's where you would find out if there was only one solution, then when you do this 180 minus 124 minus this, sometimes you get a negative angle here for your third angle. And that's when you know, okay, this is not possible, then I can't have an A this big. But in this case, the B came out positive, so everything's okay. This scenario is feasible. There are two possible triangles with angle C measuring this, side A measuring 8.61 feet, and side C measuring 5.21 feet. To find the side B that goes along with this, you would use law of sines. So you would have this equal to side C 5.21 over sine of angle C 29 degrees 50 minutes, so plus 5/6. And this would be over sine of B, which is 25.5 we just found. So you'd multiply by sine of 25.5 on both sides so that it cancels here. Enter all of this into your calculator. Be careful with parentheses here. And you should get side B2 about 4.5 feet. And there is your second triangle.